Hello everyone. Today, we will study the contact-type dampening devices of offset printing presses. Offset printing utilizes the immiscibility of oil and water to achieve ink transfer. During printing, the plate is first dampened with water so that the hydrophilic non-image areas repel ink, and then inked so that the image areas receive ink. Therefore, in addition to the inking devices, an offset press must also have a dampening devices to supply water to the plate. The dampening devices must stably and uniformly apply an appropriate film of dampening solution to the plate during printing, and allow easy adjustment of the film thickness to achieve ink-water balance. Dampening devices can be divided into contact type and non-contact type. Contact type dampening, the water from the fountain roller is transferred to the plate through various rollers via direct contact. Non-contact dampening, the water from the fountain roller is transferred to the plate without direct contact. The advantage of non-contact type: prevents water, paper lint, dust, and emulsified ink from contaminating the dampening solution. The disadvantage: higher water consumption and less uniform water distribution, affecting print quality. This lesson focuses on contact-type dampening devices. First, contact-type dampening devices. Contact-type dampening devices mainly include intermittent and continuous types. 1. Intermittent dampening devices. Figure 1 shows the working diagram of the intermittent dampening devices used in Bayron J2203 and J2108 offset presses. The intermittent dampening devices consists of water supply section, water distribution section, and dampening section. Water supply section includes water pan, fountain roller, and oscillating transfer roller. The function is that supplies a controlled amount of water to the distribution section. The fountain roller can rotate either intermittently or continuously, if driven by a DC motor for continuous rotation. The fountain roller is usually uncovered. In this moment, it requires a highly polished surface. The oscillating transfer roller swings between the fountain roller and the vibrator roller. When it comes into contact with either the fountain roller or the dampening distributing roller, it rotates around its own axis, relying on frictional force, achieving intermittent water transfer. The water distributing part contains only one dampening distributing roller. Its function is to spread water evenly in both the circumferential and axial directions, and deliver it to the dampening applying rollers, while the dampening distributing roller rotates mandatorily. It also moves axially. The surface linear velocity of the roller is equal to that of the plate cylinder. To enhance the hydrophilic property of the surface of the dampening distributing roller, it is generally chrome-plated. The dampening applying part consists of two dampening applying rollers, which are used to evenly coat water on the non-image areas of the plate 6. The dampening applying rollers rotate due to the mutual friction when in contact with the dampening distributing roller and the plate cylinder. The surface roughness and hardness requirements for the dampening distributing roller involved in this mutual friction are quite high. Both the dampening transfer roller and the dampening applying rollers are covered with sleeves made of materials such as flannelette. Its drawback is that it is very slow to respond to changes in water feeding conditions. Even when the water amount is adjusted to the optimal level, the amount of water on the plate and transferred to the paper is still relatively large, which affects the quality of printed products. Second, continuous dampening device. In a continuous dampening device, the intermittently rotating fountain roller is replaced with a continuously rotating one, and the reciprocating dampening transfer roller is removed, enabling continuous supply of water for plate dampening. 1. Dampening device, where the dampening applying roller directly dampens the plate individually. The figure shows the Komori contact type continuous dampening device from Japan. The fountain roller 1 is independently driven by a motor and rotates slowly. The water supply amount can be adjusted by varying the motor speed. The dampening distributing roller 3 and the dampening applying roller 4 are driven by the gear at the end of the plate cylinder shaft. Their surface linear velocities are equal to that of the plate cylinder surface, and they rotate relatively fast. Therefore, not only do the metering roller 2 and the dampening distributing roller 3 rotate at different speeds, but also their rotation directions at the contact point are opposite. This forms a thinner dampening film between the two rollers to achieve uniform dampening of the plate. In the figure, 5 is the pressure roller 2 device where the first ink applying roller dampens the plate, as shown in the figure. This device was designed by Harold Dahlgren, an American, and is also known as the Dahlgren dampening device. Its remarkable feature is the simultaneous application of water and ink. The chrome-plated fountain roller 1 is independently driven by a dedicated motor. The surface linear velocity of the fountain roller is 20% to 50% lower than that of the plate cylinder surface. The metering roller 2 is driven to rotate by the fountain roller. The amount of water applied can be adjusted by changing the gap between them. The fountain roller 1 is in direct contact with the first ink applying roller 3. When the fountain roller and the ink applying roller 3 slide relative to each other, a thinner and uniform water film is formed due to the speed difference. And this water film is coated onto the plate via the ink applying roller 3. The ink applying roller 3 applies both ink and dampening solution to the plate simultaneously, serving as both an ink applying roller and a dampening applying roller. This device has a simple structure and is easy to operate. It uses a small amount of dampening water, enables fast drying of printed products, facilitates register, and reduces the reject rate. This concludes today's lesson.